Shutting down Proteus meningitis, an overview and control plan for Blumkin's disease.
The vector of Blumkin's disease is Anopheles bradleyi, which is a part of the Anopheles crucians complex, and even used to be considered a subspecies of Anopheles crucians. They are so closely related, in fact, that they cannot be identified morphologically until they are fourth instar larvae. Just like other species of mosquitoes, their life cycle is holometabolous, meaning they have life stages that include eggs, larvae, pupae, and then adult. Male adults feed on nectar and other sources of glucose, while female adults take blood meals for development of eggs. Their preferred hosts are mammals, mostly humans, with the occasional cattle or rodent. In the photograph on your left, you can see the mouthparts of Anopheles bradleyi, which include its long maxillary palps, while in the photo on your right, you can see a larval and pupal mosquito and how they sit in the water at those stages in their life cycle. The ecology of Anopheles bradleyi. They are found along the Gulf Coast of Mexico and along the northeast coast of the United States. Primarily in wet, marshy regions, they are weak flyers and don't go more than 2 miles away from their breeding grounds. They begin pupating in the beginning of April and mate throughout the summer. Anopheles bradleyi breed in many different environments. Unlike Anopheles crucians, Anopheles bradleyi larvae can survive in salty, stagnant water.
People of any age or background can contract Blumkin's disease. However, some individuals are at an increased risk to develop the disease. Younger or much older individuals have a greater chance of becoming a host because of their weaker immune systems. In addition, individuals who spend high amounts of time outdoors are at an increased risk of becoming hosts, since they are spending more time around the vector of the disease. While on the topic of the vector, the area of exposure for the host will be anywhere that the vector, Anopheles bradleyi, can feed off of them and spread the disease. This will happen more often in outdoor areas that are warm and wet. Some examples of this would be parks with standing water, around ponds, swamps, marshes, or even your own backyard. Furthermore, since the area of exposure follows that of our vector, logically, the geographical range of the host will do the same. Since the southeastern United States coast is the perfect breeding ground for Anopheles bradleyi, this will be the general range of the hosts.
We found the reservoir for this disease to be Paromyscus polionotus, more commonly known as the oldfield or the beach mouse. These mice tend to have fawn-colored upperparts with more pale or whitish underparts, as you can see in the pictures below. However, this can vary with their geography. Generally, the more inland mice are darker, while the coastal distributions can be lighter, even white. The inland mice also tend to have shorter tails than the coastal mice. They range from 12.2 to 13.8 centimeters long and can weigh anywhere from 8 to 19 grams to give you some idea of their size. So, looking at their range and habitat, these mice have a geographic distribution all throughout the southeastern United States, going from northeastern Mississippi to western South Carolina, south through Alabama and Georgia, and to western and most of the peninsular Florida. Its habitat mostly consists of shrubland, grassland, and marine coastal habitat. It has a preference for dry and sandy fields, which have grass and shrub cover. However, the mouse can also occupy cotton or corn fields in the area, which have the sandy soil that it needs to form its burrows. Now, looking at the interactions that our mouse has with the vector. Typically, the mouse is a small mammal, which is the preferred host of our vectoring mosquito. Additionally, the mouse is nocturnal. This means that during the day, the mouse will be resting in its burrow, and then during dusk, the mouse will emerge to forage for food and continue this through dawn. This foraging period overlaps exactly with the feeding time of our Anopheles bradleyi mosquitoes. Finally, both the mouse and the mosquito do occupy the same geographic regions, making the beach mouse an ideal host for our vector.
Blumkin's disease is caused by the bacteria Proteus meningitis, which is found in the very large family of Enterobacteriaceae. The shape of the bacteria is bacilli, and it comes out gram-negative for any clinical testing. It also produces endospores, meaning that it is very difficult to get rid of when it is found in stressed conditions. Many of the Proteus species are commonly found in the human gut microbiota, and it also often causes UTIs.
Blumkin's disease has common and extreme symptoms. The common ones include flu-like symptoms, which are high fever, headache, and fatigue, which, as we know, all vector-borne diseases have. The symptoms of Proteus meningitis include the Koenig sign, which is severe stiffness of the hamstrings, causing an inability to straighten the leg when the hip is flexed to 90 degrees, as you can see in this picture. And Brudzinski's sign, which is severe neck stiffness, causing a patient's hips and knees to flex when the neck is flexed, as you can see in this picture. The extreme symptoms include loss of appetite, photophobia, which is a sensitivity to light, confusion, such as strange speech and hallucinations, bruising, rashing, and seizures.
The comprehensive control plan. The links that we shall be breaking are host vector, vector pathogen, pathogen reservoir, reservoir host, vector reservoir, and host pathogen. The host vector link. We will be eliminating this link by including traps for the Anopheles bradii mosquito along the coastal regions affected by Blumkin's disease. These traps will include octanol and CO2 to ensure that larger numbers of Anopheles bradii are caught, rather than trapping other mosquitoes not related to this disease. We will also be releasing mosquito fish into the large bodies of water in the area, so the larva of this mosquito is also eaten. However, we will have to monitor the effects on the ecosystem this will have to ensure the addition of a new species does not affect the ecosystem in a negative way. Finally, we will notify the public about not visiting these woodlands and wetted areas without proper protection. We will also advise them from visiting these areas during the times of dawn and dusk to ensure maximum protection against the mosquito.
The vector pathogen link. We will be releasing genetically modified mosquitoes so that they are no longer competent vectors. The modifications will be made in the mosquito's genome that make it where the bacterium will no longer be able to survive in the GI tract of the mosquitoes. We will be releasing these mosquitoes after the trapping part of the protocol is completed. That way we do not end up trapping our genetically modified mosquitoes. We are also going to be releasing these mosquitoes in places where people don't necessarily live, so that they will not have a negative response towards these mosquitoes.
The pathogen reservoir link. We will be using aerial vaccines in the form of food pellets to distribute the vaccine to the mice population in the affected areas. Ideally, we would like at least 50% immunity in the mice population against this disease to have adequate herd immunity for the disease. Currently, this method is being used by the Texas Department of State Health Services against the rabies virus coming up from Mexico in the fox population. There is no way to ensure that only the mice eat the pellets, however, this is not necessarily a terrible thing. Other rodents may be able to eat these pellets and receive immunity to this disease, preventing them from also becoming reservoirs to Blumkin's disease.
The reservoir host link. There is no known way for the pathogen to go directly from mice to humans. This link will need to be broken on an individual level. This link can be broken by setting up mice traps around the homes and public locations where these mice are found. This will reduce the possibility of any direct transmission from the mice to the humans. We will also need to make sure that people going out into marshy and wooded areas are wearing proper clothing and staying away from mouse burrows so that they don't get bitten. The vector reservoir link. This link is already being broken by some other steps in the control program. Those steps include changing the Anopheles bradleyi genome to where they cannot hold the bacterium Proteus meningitis, controlling the Anopheles bradleyi population, and establishing herd immunity among the mice species. Also, this is controlled by limiting the interactions between humans, mice, and mosquitoes.
The host pathogen link. This link has already been addressed in us using a vaccine against Blumkin's disease. However, this has not been successful due to negative public opinion surrounding the vaccine. A vaccine was originally chosen due to the quick onset of symptoms and death occurring within at least 48 hours. To adjust this negative public opinion, we will be sending our vaccine to as many independent research facilities worldwide as possible to ensure that the public has adequate, independent, and unbiased test results about our vaccine's effectiveness and its safety. We will also inform the public that the antibiotics currently available do not act quick enough against our disease, and so death will onset faster than the effects of the antibiotics against our pathogen. Finally, pamphlets, TV warnings, and informational seminars will be released into the public containing information about the severity of the disease. We will also include photos of these extreme symptoms to press in the point that this is a very dangerous disease, and overall, the disease itself is far more dangerous than any vaccine we will release into the public.
Controlling relapses of Blumkin's disease. Vaccine stores will be kept inside of pharmacies and by the government in potential risk areas for this disease to come back up. When a disease-specific fast-acting antibiotic is available, it will be stored in local hospitals and pharmacies available to the general public. We will reestablish the Anopheles bradleyi and house-mouse control measures using traps, the immune system modifying measures, and the vaccine pellets. Since mice live short lives, the vaccine pellets will be dropped yearly or bi-yearly to ensure that each new generation of mice has the immunity towards Blumkin's disease.
In conclusion, we have taken into account all the different ways in which this pathogen can spread throughout the environment and infect humans. With this, we have created several different control methods that inhibit the spread of the disease at each link of the transmission cycle. The main steps for our plan include vaccination against the disease and controlling the interactions with the vector and the human host. If each of these steps are followed through to the best of their ability, we will be able to stop the spread of Blumkin's disease and hopefully save thousands of lives.